Kuto, do you mind just moving that bag there? That orange one. No, that's your orange bag. Yeah. Thanks. Sheesh. Okay, let's see. I'll just have to wait here a bit. I was ready for the tea. Was. Are you guys as nervous as I am?
So nervous.
Okay. Yeah, that makes me nervous. Let's see. Alright. Okay, just I'll try to check also the comments on the other phone. Hey, good afternoon, everybody. Good afternoon. Okay, so I'm just going to wait in and just a little bit so that because we had to change the link that we are using to stream. Am I proper? Okay. Awesome stuff. All right. Hello to all of you that are live with us on YouTube. Okay, we've got a live audience right here in class. Say woo! Woo! All right. So I'm just going to try and log in so that I'm able to see your comments. All right. So if you guys have to ask questions, I want to be able to see them. All right. So yeah, how we are going to do this today is one. I hope that the questions that I will actually put on board will be visible, but I'll try to narrate as much as I possibly can. We've got a view of the board that we've got here. I will be seated right there. So please guys, do interact. If there are any questions that you have, firstly I'll prioritize the questions that have been sent to me by the people in our class. But I've also got an online audience that I need to actually admit. I almost forgot that. All right, let me just make sure that I can admit those that are joining us online. All right. Huh? They can hear me? Okay. All right, I'll try to. Okay. Let's just check sound. Then, good morning, good day, rather, to all of you that are online. I hope that you can hear me. I'm trying to check in the Oh, they say cool jacket. Thanks. Okay, I'm trying to check if I am visible. Can you guys hear me? Please indicate online if you can hear me. To those of you that are joining us online, please confirm if you can hear as well. Okay, right. Can you please just switch off the lights there? Okay. I hope that it's still visible. Alright guys, this is the first time that we're having this kind of a live stream, so we are trying out quite a number of things. So I hope that
that's good.
Okay. No.
Is it okay?
It's too far.
All right. Am I audible? Thank you. All right. I hope that the settings will be okay now.
It's too far.
Is it too far?
You can't see.
Yeah, it is. And when you zoom, it becomes blurry.
Let's see. You know, yesterday we had this game. Okay, so what I'll have to do is, I think once I start writing, perhaps I'm hoping that I'll be, then it will, let's see if I go onto the board. X plus 2. You've got what? So, Anika,
Yes?
so we don't need the other window.
Yeah, I'm just
Yeah.
getting closer.
Right now I'm seeing both of them. We don't need that.
Can I just...
Okay. All right. Hopefully we are ultimately going to get this right. The funny thing is that when we tested yesterday, it worked quite perfectly.
This sounds fine. Yeah, this sounds perfect.
Okay. No, so what it has done is that they've cropped out a part of the screen.
I think that one just needs the
Okay. So I'll just need to be mindful when I write then, Alright. Okay, let's go for it. Okay, Sangonani Nonke. I hope that you guys are well. For those of you that are online, I do apologize. So we are live on YouTube as well. So we are trying out this new format of live streaming. Please, I hope that you don't mind the glitches. We tried to actually test this yesterday. For some reason, it worked much better than it is today. So hopefully, we are eventually going to get into what it was yesterday. Alright, we're still trying it out, guys. Please just, for now, I'm seeing all your greetings. Thank you so much for those who appreciate the effort. Alright, so I have several questions that I have received from you. Now, I'm mindful, some of the sections that we are going to go through today, we haven't really gone through in our class, right? But what I'll try to do is I'll try to kind of, answer those pertinent issues that are there. And please, to engage, okay? They won't see your faces, but certainly when you do ask a question, please do be mindful that there's an audience that's online that would like for you and they'd like to hear your question as well, so that they can be able to engage. Right, now this question, I don't know where some of the questions actually come from, so you'll forgive me if they are not as visible. If I could source them from past exam question papers directly, that would help quite a lot. But what I will do is try to just answer them. As I said, some of them are really impromptu. They were sent to me. Right. So this question 6.2. Okay, let me try to zoom in a bit. So it says exactly 10 months ago, a bank granted Jane a loan, right? So at an interest rate of 10.25% per annum. Are you okay?
They can't see.
They can't see. No, it's okay. They'll see once I write. At least I can read it to them for now. They'll see once I start writing. At least the writing will be a bit more visible. So I will just try to extract the information out. Okay, right. So 800,000. So that's the loan amount, right? So that's what Jane is taking out as a loan. And they say to us, at an interest rate of 10.25% per annum, that is compounded on a monthly basis, right? Now they say the bank stipulated that the loan must be repaid over 20 years, so we know the period of repayment, the repayment period, right? And then they say to us it must also be paid by means of a monthly repayment of 7,853.15 starting 1 month after the loan was granted. Now guys, when it comes to loans, and I want you to think about it, right? I did say this in my lesson. When it comes to loans, so first of all, we know the principal amount of 800,000, or rather the loan amount that was given, right? So the amount is 800,000. And then secondly, oh gosh, and that's 7,853 rand and 15 cents. Now this is the repayment, so that's the monthly repayment that we are supposed to have when we are repaying this loan, okay? So now they tell us, or rather they are asking us a question. How much did Jane owe immediately after making the 6th repayment? Okay? So what happens in this case? Let's draw our timeline. So let's say here on our timeline, this is when the loan was granted, that's 800,000. Alright? Now, it's very uncommon that you would repay a loan on the same day that you are granted the loan, isn't it? So there's always that month gap that you must factor in, right? However, so let's say this is month 1, that's month 2, that's month 3, and they continue. Now think about it. How many months do we have up until we've got 20 years, right? So you'll say 20 multiplied by 12, so which means that you've got 240 months. Are we all okay, guys? No? Right. So in this case, remember we've got 12 months. Okay, let me just switch this guy off. Otherwise it will keep giving us some issues. So remember, in this case, what we actually have is that we've got the number of months as well as the number of repayment, rather the amount that we are supposed to repay. So we want to know, on the 6th repayment, right, they say how much did Jane owe immediately after making the 6th repayment, okay? So she paid an amount of 7,853 and 15 cents on the first month. She did so on the second month, right? And we want to know, after she had paid this amount over here, what is the balance on the loan? Right, now guys, I want you to please listen very carefully. Right? What am I looking for? I am looking for the balance at this point here. There are two ways of calculating balance on a loan. Right? So I'm going to show you the first one. So the balance of a loan, you can think about it this way. There's still an outstanding amount that must still be repaid over the remainder of the period. Do you agree with me? No? We know that what that amount is, or rather we know how much will be repaid, but we now need to find out how many months are still outstanding. Are you guys with me? No? So, how many months has she paid? She's paid for 6 months since the granting of the loan. So I want you to note that when I now take the balance of this loan, I can say, well, this would be, I can look at the remaining number of months as my repayment terms, and I want to know what is the present value at this point over here. Are you guys with me now? Right. What would be the present value for the outstanding period for which this person is going to pay? Jane, right? So the balance in this case would be equal to the present value, right? It's as though, you know, she is still repaying off a specific amount, but we want to know what exactly is that amount that must be repaid. Does that make sense, guys? Right. So what I want us to do is we need to now calculate how many months are still left for that period. How many months are still left? Right? So she's paid for 6 out of the 240. How many months are still left? Right, 234, isn't it? So which means that now, remember the formula for the present value. We say x into, now please I want you to note, guys, when we take the present value formula, that would be 1 minus I over, what is that formula? M, right? Please remind me, because I'm busy with these live tests. Please remind me what's that formula for present value?
Negative n.
Right? That's minus n, right?
Yes.
Okay?
Over I.
Over I. Okay. Right. So, in this case, I want you to note what amount are we paying off? We are paying off an amount of 7,853, right? 7,853 and 15 cents, right? Now, what was our interest component? Sorry, 1 minus. What was our interest component? Our interest component in this case, they had told us that this is 10.25%. Are you guys with me now? Right, but it is compounded on a monthly basis. Okay, so that means that I am going to say that's 10.25, but remember we divide that by 100. 100, but also we need to now divide by the compounding period. Are we together? So that's going to be 0.1, is it 10.25, no?
Yes.
0.1025, right, divided by 12. But how many months are we repaying this for?
234.
We said this is 234. That's the outstanding period, right? And so this is divided by 0.1025, and this is divided by 12. All right. Okay, so I hope you're going to do this with me. Right, so let's do that on our calculator. So I've got 7,853 0.15. Yes, please go ahead. Is there a question online? Over 12. And we've got it's minus 234, and this is divided by 0.1025. Remember, you are dividing this by 12 as well. All right. Now, all right, so we get, I'm not sure if the value that I'm getting there is what you got.
No, so you're supposed to put two brackets on your formula, I think, because it's x open big bracket 1 minus.
Did you guys get a different answer? What's your answer?
793.
700.
700.
Okay, I don't know what I did differently.
The formula, I think you're supposed to say x open bracket 1 minus open bracket 1 plus I close bracket to the power negative n close the big bracket.
Okay.
Over I.
All right. So you're saying that what I wrote there is incorrect. Okay. Okay. So let's erase that. Okay. Please give me the correct formula.
X.
So we said x.
Open bracket 1 minus.
Yeah. So that's 1 minus.
Open bracket 1
That's 1.
plus I close all.
That's minus n.
Yes.
Am I whining again? Formula wrong. And you guys are not loyal, okay?
Sorry.
Divided by I. Okay. Or the never, son. Okay. Right. So let's substitute the right thing. So that's minus. That's 1 minus. That's 1 plus 0.1025 over 12. That's to the minus n, which is 234. That's what you said, right? Okay. And this is divided by our I value. And this would be 0.1025 over 12. All right. Apologies for those of you that are online. I had written the formula incorrectly. Right? Yes. Excuse me? Oh, the x value is 7,800. 7,853. 15 cents. All right. Hopefully this time we're going to get a value that is correct. So I was supposed to say Lapiano 1 minus, and I open a bracket, and this was supposed to be plus over here. Né? Okay, this guy is refusing to change now. All right. Okay. Either way. All right, but give me the value upon. What did you get for your final answer?
793,000.
793,000. 752.28. 0.28. It's a great thing that I've got a live audience here to help me. Right, so this is the answer that we are going to get. Thank you, that guy. I don't know what your actual name is, but it's written as that guy. All right, so what is this? This is the actual amount that Jane still owes. Are you guys with me? Né? So the next question, and I want you guys to please understand this. So the next question, they are now asking us, due to financial issues, difficulties, right? Jane missed the 7th, the 8th, and the 9th payments, right? She was able, oh, by the way, I wanted to show you another way to calculate loan repayment. Ishmael, I think for the sake of time, because we've got quite a lot of questions. Is it okay if I don't show you the other way? My people online are skising. I'm going to have to do so. But there is another way of actually calculating that repayment. Okay. The first thing is that you'd have to map out what would be the future value of the amount of payments that you've already made, okay? And you'll subtract it from the entire interest component that is accumulated over the period of time that the loan is granted, okay? So in actual fact, maybe let me just show you quickly. Another way to draw, or rather to calculate the balance on the loan, we can say, well, it's going to be the accumulated amount when? It's going to be the accumulated amount over the entire period, right, upon which the loan would have been actually granted. All right? So it's that entire period minus, in this case, the future value of the repayments that you've already made. Does it make sense? Okay. Please don't allow that to distract you. Don't worry, I've got a phone here, so I'll be able to moderate. Okay. Yeah. Otherwise, then you won't be able to pay attention. Okay. Right. So what am I saying? I'm saying it's going to be the accumulated amount minus the future value of what? The repayments that you've already made. So if I look at the accumulated amount, you're going to say P into 1 plus I to the exponent of n, right? This is minus, and I'll tell you what n is on each respective question, right? So that's going to be P plus 1 plus P into 1 plus I to the exponent of n minus the future value, right? Now when we're looking at the future value formula, hopefully this time we're going to do the right thing, right? Comrades. So that's x into 1 plus I exponent n, right, minus 1, isn't it? This is divided by I. Now please, I want you guys to listen very carefully. We are still trying to find out what is the balance of the loan, okay? So firstly, I find out what is the accumulated amount over the loan period. And in this case, what was the loan amount? 800,000. Do you guys agree with me? Yeah? Right? But what will that be calculated over? Right, I just want to make some space here. So that will be that will be calculated over a period of 20 years. All right? So that's 1 plus. We know that this is at an interest of 10.25. So that's 1025, né? Right? Divided by 12. But over which period? Over 240 months. Okay? So now I'm taking the entire accumulated amount over that period. Are you guys with me now? But what will I subtract? Remember, Jane has already made payments for the period of 6 months. Are you guys with me now? So I want to know what is the future value of the repayments that she's already made. So in this case, she's made 7,853 and 15 cents. Now please, I want you to listen to this very carefully, guys. Sorry, I won't be able to squeeze in everything here. I'll try, but I hope you understand it. So this is going to be 1 plus, again, 0.1025 over to the exponent of. Now please, I want you to listen very carefully, guys. What are we dealing with here? It's the future value of the payments she's already made. How many payments has she made? 6, right? So I want to know what is the future value of those repayments. So there's a -1 at the corner somewhere there that I won't be able to squeeze in, divided by 0.1025 over 12. I hope that makes sense. Okay? So what did we do? We want to find out what is the balance after the 6th payment. So we want to know what is the accumulated amount of the loan over the 20-year period minus what's already been paid, the future value of what would already have been paid. Okay, can you confirm with me that it's going to give us more or less the same answer? Ne? Okay, so sengiyasaba noku because I made a mess the last time. So that's 1 plus 0.1025. Okay, this is over 12. And this is the accumulated amount, and that's yx 240. Right. Now, we subtracted. We said this is 7,853 and 15 cents, and we use our future value formula. Yeah? That's 1 plus, again, that's 0.1025 divided by 12. Okay, this is yx, what did I do now? Yeah, I'm correct. So this is raised to the exponent of 6. That's -1. And please remember to close the bracket. Ne? And this would be divided by 0.1025 divided by 12. Okay, right, I hope that I did. Okay, something went wrong again. Okay, that was -1 over there. I did something wrong again. Did you guys get the same amount?
So, for the number of payments, is that how we supposed to have it to the number of payments that have already been made?
The number of payments that have already been made. Yeah. So think about it. I need to be looking for the balance here. Okay? Right? So what am I saying? I'm taking the total amount over that period. Right? And I'm subtracting it, but I've already made payments for 6 months. And those payments have got a future value right here. Does that make sense? Okay. Right. More or less, you should be able, guys, to get the same answer. Please, for the sake of time, may I please not dwell too much on that. Let's go to the next question. So our answer here was 793,752 and 28 cents. Okay. Right. And I will tell you in future. And please, if you watch the video on finance, I actually give a warning about these 2 methods, right? The first one will only work if the person is paying the actual stipulated amount. Can you see here, okay, they told us that she's supposed to pay this amount of 7,800 and you don't do it, right? So that method will only work if we are paying only what the bank has stipulated. But let's say Jane, because she's smart, she decides, no, actually, I want to pay off the loan even faster, right? So therefore, let me add on the amount of money that the bank has stipulated. In that case, I want you to know that that first method will actually not work. Are you guys with me, no? So please remember, it will only work when you are paying the actual minimum amount that has been stipulated by the bank. The second one is actually the fail-safe method. Okay, right, it will actually give you what will be the actual balance. All right, now let's go back to the question that we are now given. So guys, they say to us, due to financial difficulties, Jane missed the 7th, the 8th, and the 9th payment. Now please guys, I want you to constantly remember this. So now, when she misses her repayment, what happens? The balance that she had, remember, continues to accumulate interest. Does that make sense? Eh? So the balance that she would have continues to accumulate interest. So that means that for the 3 months, the 7th, the 8th, and the 9th month, we are now accumulating interest. Okay? So if we go on to, let's say, our timeline, I want to go back there. So if we go on to our timeline, let's say this is where the balance was on our timeline. Eh? Right? So this is month 6. And we said, okay, 7, 8, and 9. What's happening in that case? This loan here, she's not making repayments during that period. But what would happen? The loan is accumulating interest. Makes sense, no? So for those 3 months. So the first thing that we are going to do, we're going to get to the question in just a bit. The fact of the matter is we are going to need that accumulated, that amount with the accumulated interest. Are you guys with me? How many months has that happened? 3 months, right? So what's our principal amount? So in this case, that's A into P, 1 plus I to the exponent n. Our principal amount now becomes the balance that was there on the 6 months. Does that make sense? So, what was that amount? 700 and, please give me that value. 793,000. 752.28. So now that becomes our principal amount. Does that make sense? No? Right. Why are you looking at each other?
Exactly.
What is this guy saying? Did I say something wrong? No, but did you see it? No?
Exactly.
I just looked at each other and like, I'm not even sure. Okay, so this is going to be 1 plus. Now the interest on that, remember, still remains 0.1025, right? And now please, I want you to note, it's still compounded on a monthly basis, so we divide that by 12. But how many months does that happen? You said to me that happens over a period of 3 months. Please, can someone just calculate that for us quickly?
You get
814,000. 266.42.
If rounded off.
If rounded off. Okay, great stuff. Now, that loan has accumulated for that period, right? Now, what was the question? The question is, she was able to make the payment, right, from the end of the 10th month. Now, note, 7, 8, 9, she's missed. Okay? She's able to make the loan repayment on the 10th month. Are you guys with me? Yeah? Right. So, it means that on the 9th month, remember, whenever we are granting a loan, we always say from the granting of the loan, there's that month gap, right? And then we start calculating the repayments. Are you guys with me? Yeah? So please don't be thrown off by the fact that they say at the end of the 10th month, right? It only means loan, in a sense, granted on the 9th month, and then she starts repaying on the 10th month. Makes sense, no? Right. Now we need to find out. They say calculate Jane's increased monthly payments in order to settle the loan in the original 20 years. So what is she trying to do? Make sure that the loan period is not extended. Given that she's missed the payments, she still wants to make sure that she finishes off from the same date that initially was calculated as the finish date. Does that make sense, guys? Right, now, I want you guys to please note. So if we go onto our timeline and say, perhaps, let's look at this as the 10th month, okay? So things happened here, but we are here now. What do we owe on that 10th month? Right? In fact, rather, this is on the 9th month. We owed an amount of 814,266.42 cents. Does this make sense, guys? But what does she do? From the 10th month, she starts repaying. Does that make sense? Here's our gap. I always say between the granting of the loan to when we start repaying, we always have that gap of 1 day. Does that make sense, guys? Okay. Right. Now the question is, how many months are still outstanding? How many months are still outstanding? So here from from 10, right, all the way up until 240. We do not change our timeline. We still have those 240 months. So how many months does she now have to pay off that loan, right? I want you to note, please guys, we are including the 10th month. Please don't say 240 minus 10, right? Why? Because we're including the 10th month. So in fact, if you want to look at it as, it's actually 240 minus the 9 months, right? Because on the 10th month we are repaying, okay? So please remember, it will be 240 minus the 10 plus 1. Make sense?
Yes.
Okay, right. You're not? You're listening? Okay, intently. Okay, all right. So, in this case, now what do we want to do? We want to find out what will be the adjusted amount. So, my question again, is it future value or present value?
Present.
Whenever we've got a loan, right, we are using the present value formula. Are you guys with me? Yeah? Right, present value formula. Bonje, what do we say? That's x into? That's 1 minus 1 plus I minus n divided by I. Right, what is our present value? It's 814. It's the loan. It's the loan that she's owing. But now what do we want to find out? The adjusted amount. It's no longer going to be that 7,810, right? So now we want to know what will be the new loan amount. The interest stays the same. So this will be 1 minus. That's 1 plus 0.1025 over 12. And now this is where it becomes critical. What is our value for n? We said that's going to be, we said 240 minus 10, right? That's 230, right? But we have to add that 1. Are you guys with me? So this is going to be 231. Guys, are we good?
Yeah.
Awesome stuff. So this is divided by 0.1025 over 12. Okay. All right, I'm looking at your comments, guys. Some of them are very amusing. So please, I want you to please note, in this case, it's not going to be 230, it's going to be 231, and that's because we are also including the 10th month. Okay, so please note that. So the thing about it here, guys, from here on it just becomes mathematical gymnastics. Ne? Okay? So firstly we are going to cross multiply and divide by that entire thing. So I'm going to take that amount of 814, 266.42, and I'm going to multiply it by that fraction 0.1025 divided by 12. Okay, I get an amount. And please guys, it's a learning season on this one. Okay, I don't want to make a mess. And now I'm going to divide by that entire bracket. Okay, so this is divided by, that's 1 minus, okay, also the bracket, 1 minus, that's 1 plus, let me just make the, over 12. Please, for those of you that are online, please use your calculators as well. Let's confirm if you are able to get to the same answer. I'm going to close that bracket, and that's minus 231. Okay? And I need to make sure that I close that entire bracket. Alright, for my x value, I get an amount of 8,000, and it makes sense for her to be able to pay more, right? So I get an amount of 8,089 rands and 23 cents. So that will be the repayment, or the amount that she is meant to repay. Sorry, I'm going to remove my calculator there so that you can see it. So that is the amount that she is meant to repay back. Is good, is nice, guys? It's good? Alright. Can I get a sharp? Okay, I can see. And let me see where I can see that you've got the same value. And Bali, you've got the same value, as well as Selani. Is it Selani? Selani. Okay. You also got the same value. Alright, awesome stuff. Alright, let's do this here, guys. Let's go on to the next question. We still have quite a number of questions that I don't know if we'll be able to complete all of them, but we'll try to answer the ones that are there. Please, for those of you that are online, if you've got any questions in relation to what we have done, please, you are more than welcome to ask the question. Alright. I don't know if this one will be clearly visible, but I'm hoping that we will be able to see. Right, I'm assuming you wanted a 3.2, right? Because that's what's written there. Yes?
Yes.
Okay. Alright. Okay, so they give us an expression there. They say the sum, and I hope for those of you that are online, sorry that if you can't see it clearly, I will read the question and I will just try to annotate the things that are important. They say the sum Sn of the first n terms, right, of an arithmetic series is given by Sn. So now we know firstly this is an arithmetic series. So it's given by Sn. Right, let's switch this guy off. So that's n squared plus kn. Right? They say where k is a non-zero constant, okay, given that the fifth term is, or rather of the series is 11, find the 17th term of the series. Right. Now guys, may I please just show you what we're going to do whenever we are given the sum formula. So this represents the sum, right, of this arithmetic series. But the question is, how do we get the term number? Okay? So whenever you've got a sum, now please I want you to listen very carefully. So whenever I want to get, let's say, I'm making an example, right? Tn, it will always be Sn minus Sn minus 1. Are you guys with me now? Meaning, if I wanted to get, in this case, they gave me the 5th term. So my n value is 5. So meaning that T5, they've told me there that the 5th term is equal to 11. So T5, this would be S5 minus S4. Makes sense, no? Right. So let's substitute into our formula. T5 is given to us as 11, right? But we've got a formula there, n squared plus kn, so which means it's going to be 5 squared, so I'm substituting for n, right? So that's going to be 5 squared plus k times 5. Make sense? Minus, please put it in brackets because you are talking about an entire expression. So 5 squared minus, so now S4 is 4 squared minus k times 4. Okay? Right, and I want you to note in this case this will give us 25. And by the way, T5 was given to us as 11, isn't it? Okay? So that will give us 25 plus 5k minus, now please remember, guys, that that negative will actually multiply into that bracket. Very important. So that's going to be minus, this is 16 minus 4k. Is nice? Right, so that's 25 plus 5k, I'm just dragging this, minus 16. Note, I'm multiplying the negative inside that bracket, so that's minus 16 plus 4k. Negative times a negative will give us a positive. We good now? So we've got 25 minus 16 on this side, which gives us 9. This is 5 plus 4k will give us 9k. If we take the 9 to the other side, 11 minus 9 gives us 2, and this is equal to 9k. And so if we divide both sides by 9, your value of k divided by 9, our value for k gives us 2 over 9. Does it make sense? Right. So our value for k becomes 2 over 9. Sorry, I don't know where this question paper comes from. It would be easier if I could reference, so that you know where to look for this particular question. Now remember, they were not asking us to find the value of k. Alright? That was not what they wanted us to get. They said to us, find the 17th term of the series. Okay? So how do we find the 17th term? T17 will be equal to S17 minus S16. So that means this is going to be 17 squared plus, now we know what the value of k is, right? That's 2 over 9 times 17. That was kn. Minus, going to say 16 squared plus 2 over 9 into 16. Right, and that would be the value of our 17th term. If you can, maybe just give me an answer. Right. All right, I see there's a question here from Primrose. Sir, can you please explain where we get Sn minus Sn minus 1? So I will prove this to you. Né? Every time that you're looking at the sum of the terms, now I just want to I just take a very, a very easy example. Let's say I've got terms 1, 2, and 3, and 4, right? If I took the sum of the terms, right, and I want to show you right now, if I take the sum of the first 4 terms, this will give me 1 plus 2 plus 3 plus 4 will give me 10, right? If I take the sum of the 3 terms, this will give me 1 plus 2 plus 3, that will give me 6. And you'll note, if I wanted to get term 4, I'll always say the sum of the first 4 terms minus the sum of the first 3 terms. And you'll note, if I say 10 minus 6, that definitely gives me 4, and that is the value of your 4th term. So that's where we get that formula, and I hope that it does make sense. Squeeze nice? All right, beautiful stuff, beautiful stuff. All right, now, see right now your question, huh?
Yeah.
We can move on. All right, I saw some questions here on, okay, let me go to the calculus question that was sent, and then I'll jump to probability. All right, I saw some questions, especially on the fundamental counting principles that was sent. Hey, what did we on the fundamental counting principles. And I'll show you guys, the fundamental counting principles is really not that bad, right? Makes it quite easy for you to be able to navigate through it, okay? Right, I'm assuming that the question was 8.3,
Yes.
okay?
Maybe let's start with different one also.
Should we start with 8.1?
Yeah. And 8.3.
You see pi.
Yeah.
Pi is not an issue. Pi is
But
a
it's not something
constant.
we see every time.
Okay, all right. Okay, so we want to find out. We're starting with 8.1, and I'm hoping for those of you that are online, I'm going to rewrite it. So they want us to determine by first principles. So we've got f of x, which is equal to 5 minus, this guy is really giving us an issue. Yes, the people here in class are not loyal. Yes, you can see what my device is dying, Mara. You are not warning me. So 5 minus pi squared x, is it x cubed, no? Right. So they want us to get this from first principles. And please, I want you to note, guys, whenever we are trying to find the derivative from first principles, so we've got f of x plus h. Let's write that down first, right? So which means everywhere I see x on my formula, I am going to replace it with f of x plus h, or with x plus h. So this is going to be 5. That's going to be 5 minus pi squared. Remember, pi is not a variable. It is not a variable. Pi is actually Gonyo, what is it? Gonyo, what is it? It's a constant. It's a constant. It's like saying 3 times something something. So this is going to be cubed. Hey guys, this is a lot of work, né? Right. So I want you to note, we have this. So let's do this for ourselves. To make things a little bit easier, let's try and expand on what we have, right? Okay. So remember, when you expand on this, you've got 5 minus, we still have that pi squared over there. But now let's expand. We've got x plus h into x plus h into x plus h. Are you guys with me, yeah? Right. So this would be x plus h into the quadratic form of x plus h. So I'm writing this as pi squared into x plus h into x plus h squared. Now, There's an easier way of doing this, but for the sake of not causing confusion, I will still just expand as per normal. So we've got x squared plus 2xh plus h squared. That's what we have, isn't it? Okay? So remember, all that we're going to do is just expand on what we already have. Now please, I want you to note. So we've got 5 minus pi squared. So let's deal with what we have there. We've got x cubed, right? That's the first one. What do we have? We've got 2x squared h times h. We've got x plus x times h squared, which gives us xh squared. Is this right, Annette? Right. So we've got h multiplied by x squared, which will give us h x squared, or you can say x squared h, it makes it easier to recognize later. That's x squared h. And I want you to note, what do we have? We've got 2 plus 2 xh squared, and you've got plus h cubed. So I wanted to show you guys, when you've got something like this, that's 5 minus pi into, I hope they don't give you something like this, right? So what do we have? Sorry, this was supposed to be x cubed. Sorry about that. Right? So this is x cubed. Now notice, like terms, we've got 3 x squared h. Can you see? You've got another like term, xh squared, xh squared. You've got another 3 xh squared, and you've got h cubed. So please note that whenever you are squaring, or rather you are cubing a bracket, okay, that's how it always works out. Né? I wish I had all the time in the world so that I could show you with different examples. Now, let's go for it here, guys. So you can add pi there, right? So that's 5 minus, you've got pi
Squared.
huh?
Pi squared.
Oh, rather, sorry, that's pi squared. We've got pi squared x cubed plus 3 pi squared x squared h. You just need to be meticulous about the details here, nah? Plus 3 pi squared x h squared plus pi squared h cubed. So that's what you have as f of x plus h. Are you guys with me now? Right. Now, what is the formula for finding the derivative? So, to find the derivative, we say limit. Okay, there's a question online. Yes, please go ahead.
So is it not going to be minus pi when we're multiplying inside the bracket?
You are absolutely correct. So which means everything now becomes negative, né? Yeah, I was either meant to put the bracket there, or if I'm multiplying into a bracket, then that negative, the pi, changes every single one of those brackets to become negative. Every single one of those terms, rather, to become negative. So in this case, what do I have? Right? So remember, we say this is limit as h tends to 0. Now please, guys, you do not drop this until you substitute the 0. Okay? So limit as h tends to 0 of f of x plus h minus f of x divided by h. So let's do this. Because we're going to need the space, so limit as h tends to 0. Now what is our f of x plus h? It's that entire expression over there. So I'm going to divide there by h, but what's our expression? It's 5. Let's switch this guy off again. Minus pi squared, x cubed rather, minus 3 pi squared x squared h. Ooh, they're really testing our patience now. Minus 3 pi squared x h squared minus pi squared h cubed, right? And this is going to be minus f of x. And remember, our f of x was simply 5 minus pi squared x cubed, right? So this is going to be, sorry, I'm going to try and squeeze this in here. That's 5 minus pi squared x cubed. So you'll see that most of the terms, or the ones that, the critical ones, the ones without h, will actually cancel each other out. Are you guys with me now? Right. So if I simplify this, that's limit as h tends to 0. You look like it's exhausted you already, no? Right, so it's 5 minus pi squared x cubed minus 3 pi squared x squared h minus 3 pi squared x h squared minus pi squared h cubed. Now note, this becomes minus 5 plus, okay, remember, I'm multiplying that negative into that bracket, no? That's plus pi squared x cubed rather. Please guys, don't blame me for these questions. You sent them, no? So if you are losing patience, I'm not responsible. You sent me these questions. Okay. So that's positive 5 and negative 5 cancel out. Note that a negative pi squared x cubed, positive pi squared x cubed cancel each other out. Now note what we have left. Are you guys with me now? What do we have left? We've got all of these terms that are left, and all of them have got an h in them. Alright? So allow me to do this. I'll take out the h at the top. Sorry, I still need to write the limit as h tends to 0. So I'll take out the h. Now note, for this first one, I will have minus 3 pi squared x squared. Alright? For the next one, I will have 3 pi squared x with 1h. We're still good? For the next one, you've got minus pi squared h squared. And this is all divided by h. And now, because we are able to cancel out the h, what does it mean? It means we can substitute a 0 for the h, right? So I don't need to write that limit h tends to 0 now because I am substituting that h. So what am I left with? I've got minus 3 pi squared x squared. Everywhere I see h, I'm going to substitute 0. Minus 3 pi squared x times 0. So that thing cancels out. Minus pi squared. Remember that our h is 0, so that's going to be 0 squared. And so that means that f prime of x, what does it give us? That would be minus 3 pi squared x squared. Squeeze nice, eh? Alright. It wasn't a nice one, but we struggled and made do, right? Okay. For 5 marks. How many marks did you want? I see B. Mabunda says, this was supposed to be 7 marks.
Exactly. Or 6.
Or 6 at least, okay. Alright. Alright, let's go for the next question. Let's go for the next question. Right, now I wanted to go to that question. Guys, please, you'll be able to continue this on your own. I really want to get to those critical questions. Now, for the next question, what they did here, okay, let me do this so that maybe for the sake of space and time, let me try and just move it down so that. Right, so let me move this down. So here we are. What do they say to us? We've got g of x, which is equals to m of x plus t. They say this is a tangent to the function of f. Now please, I want you to remember, whenever we've got something which is a tangent, okay, it doesn't matter what our function looks like. What do we note about a tangent? Right? It touches the graph at one point. So they share a common point. Are you guys with me now? So the tangent together with the function would share a common point. Now they tell us, Uti, this is a tangent whose gradient is given by f prime of x. So the gradient of this tangent is f prime of x, which is 3x minus 1, all squared plus n. Okay? And they say if it is given that g of 3 is equal to minus 58n. Now please, I want you to note, what are they giving us there? Right? They're giving us a point on the graph of g. Are you guys with me now? They say determine the values of n, m, and t. Whew. I know, guys. Can't listen in that. Huh? What did you do? Right. So first of all, I've got a point. Nah? Where g is equal to 3, what is our y value? Minus 58n. Are you guys with me? Huh? Right. So I know that g of 3. So I'm going to say this is m. Where I see x, I'm going to put 3. This is plus t. But what does this give us? Negative 58n. Okay? So that is going to be 3m plus t is equal to negative 58n. Now, I don't know, maybe we can make t the subject of the formula, né? Okay, so let's say t would be equal to minus 58n minus 3m. Alright? And I'll call this equation 1. Obviously, we've got 3 variables, so which means if we've got 3 variables, we need 3 equations, guys. Okay? We need 3 equations. Now, another very important thing, what do we note about G? They said it is the tangent to the graph of f. Does that make sense, guys? Yes. So what does that mean to us? That the gradient of G is equal to the derivative of f at a particular point. Does it make sense, guys? Right. So in this case, the gradient, so I've got the derivative of f prime x, right? And I know that it will be equal to the gradient at whatever particular point that we have. So, what is the gradient of G? The gradient of G is M. Sorry, I'm trying to get a different color here. What's the gradient of the tangent? It's M. Are you guys with me now? Right? And I know that the tangent, the derivative, so f prime, okay, let me take a different color. So f prime of x, that's given to me there as 3x minus 1 whole squared plus n. That's 3x minus 1 all squared. This is plus n, or is it minus? Plus n. Right? What is it equal to? It's equal to n. Does this make sense, guys? Right. We say that the derivative, alright, or the gradient of the tangent is equal to the derivative at that particular point. We all good now? Right. So we want the x value in this case where those are equal to each other. So we've got so we've got 3x minus 1 all squared plus n. And by the way, did they not give us the x value where they are equal? So 3 is minus 58n. Okay, no, they didn't. So we've got g of x is mx plus t is a tangent whose gradient if it is given that, so we've got okay, so I'm trying to see in this case how I can relate these two. So g of x is mx plus t. So that was equal to the gradient. Okay, so we said that was m over there is equal to the derivative at f. Yeah, I'm trying to see if, can we not have a common point? Because that would help. Yes, yes.
I wanted to ask, since f prime of x is like the quadratic and it has 1 as a PQ type of coordinate thing,
Yeah.
how can you use that?
Since it is a quadratic equation and it has 1.
The turning point coordinate.
Yeah.
So like positive 1 and n as the PQ, and then you could use those coordinates to find the common point.
So the thing about it, okay, so she's asking, can we not use the fact that this guy is a quadratic expression, right? The fact that this guy is a quadratic expression, and the fact that we've got negative 1 over there, and so we've got the p and q value, so we've got the turning point,
Yes.
right, of the derivative formula. Yeah, but we don't know if it meets at the turning point. Yeah, so that's our issue. So g of x, okay, let me think about it a little bit. So we've got g of x, which is mx plus t, is the tangent, okay? So which means the derivative of this guy is equal to, so the gradient rather, is equal to the derivative at a point. So this is g of x. So this guy here is g of x, which is mx plus t. Okay? Right, now, okay, so we've got this guy. So the thing about it, Wuti, they actually had not given us the coordinates of where this thing would meet. Okay? Whose function? Alright. Maybe let's come back to this one if we still have time. Ne? Yeah, I don't want it eating up on whatever precious time that we've got. I'll think about it a bit, and if I can, I'll try to, if it is possible, then I can post a video on the solution. Okay? Right, so I'll do that. Okay, let's go to the next one. I did say that I wanted to look at some questions on the. This was another interesting question. I think this was optimization. Eh?
Yeah.
It's based on optimization. Okay. I think because of time, can I go through the questions as the probability and the fundamental counting principles? Ne? Maybe let me run to that. So that we are able to do those together. I'll come back to that question. So we can only run up until at a maximum we can only stop at 2 o'clock, because I do have another engagement. So let's go for it quickly. So they say to us we've got a 4-digit code is required to open a combination lock. Okay? Right, the code must be even numbered. That's very important. Ne? The code must be even numbered. Now, wait. In order for a number to be an even number, what has to happen? Excuse me?
It has to be divisible.
It has to be divisible by 2, right? It has to be divisible by 2. But what's the condition? If it's a 4-digit code and it's an even number, what has to happen to the last number? That last digit has to be the one that's divisible by 2. Does that make sense? Okay? Right. So they say to us, the code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated. So that becomes very important. Now guys, I want you to listen very carefully. Whenever you are doing questions on the fundamental counting principle, now I know there are all of these difficult formulae that you always get. Né? I never use them, right? I want you to kind of draw the scenario for yourself, the combination of numbers. Now, firstly, how many numbers do we need? How many digits, or rather, what's our code looking like? It has 4 digits, né? Right, so there are my spaces. I've got 4 digits. So I want you guys to note, they say the 4-digit code is required for the combination lock. The code must be even numbered, okay? So we may not use 0 or 1, all right? Now how many digits are we left with? So anything in between, right? We've got 10 digits in total, but we may not use 0 and 1. So how many digits are we left with?
4.
Huh? How many digits can we use? All of the others, right? All of the others. We can use the 8 digits. Are you guys with me? However, the condition is that digits may not be repeated, and secondly, the code must be even numbered. Now, for a number to be an even number, let me make an example for you. For it to be an even number, is this an even number? Why? Because the last digit is divisible by 2. Are you with me? So for it to be an even number, the last digit has to be divisible by 2. Are you guys with me now? And this is to the exclusion of 0, because they said we may not use 0. So let's start with that condition in mind. Okay? So you kind of start at the end. Right. So for the last digit, how many digits can I use? I can use 2, I can use 4, I can use 6, I can use 8. How many digits? 4. Right? So I can use those 4 digits. Okay? And by the way, I'm already answering the first question. How many possible digit combinations are there to open the lock? So I can use those 4 digits. Now then let's start at the beginning. Right? So at the beginning, how many digits can I use? So I can use any of the 8 digits except the one that I've already used over there. Does that make sense, guys? Right? So, in this case, please I want you to note that I have 2 possibilities over here. Right? So, if this guy, I can make this from odd numbers, or I can use even numbers. Now please, I want you to note, on fundamental counting principle, when I've got 2 possibilities, I can actually add those probabilities. Are you guys with me now? Right, now please, I want you to listen very carefully. So this is the event when I use an even number and when I use the odd number respectively. Now, if I am using odd numbers for my first digit, okay, I want you guys to note, if I'm going to be using odd numbers, how many odd numbers are there? Right? Between 1, remember 1 is excluded, isn't it? Right. How many odd numbers?
3.
So we've got 3, we've got 5, we've got 7, and we've got 9. Are you guys with me? So 4 odd numbers. Are you guys with me? Right. Now that I've used those odd numbers, right, how many numbers can I use here? Right? I've used even number here. I've used one of the odd numbers here. How many numbers am I left with? Remember, between 2 and 3, I can use anything. Are you guys with me now? Right, so between 2 and 3, I can use anything. I've already used 2 numbers. How many do I have left? How many digits do I have left? I've got 6, right? Now I've used 3 digits. How many can I use? How many digits can I use? 5. Does it make sense? Yeah, it's one of those. It's one of those. We just need to think about it just a little bit. Right. So we've got another possibility, right? If we use an even number. Now remember, again, for this possibility here, I can still use how many even numbers? How many even numbers do I have? I've got 4, no? So again, 4 even numbers, but that's now on condition that I use an even number on the first as the first digit. If I've already used 1 here, how many even numbers do I have left? Right? How many even numbers do I have left? I've got 3. So this means that this is going to be 3 over there. But I've already used 2 numbers, right? In this case, how many scenarios do I have left? How many digits do I have left? Right? Even or odd. Remember, for the second and the third one, I still have 6 that are left, and in this case, that would be 5. Did this make sense, guys? Right. So, which means that the number of possible digits that I can have will be 4 times 6 times 5 times 4 plus, remember that's another possibility, right? And the possibility that I use an even number, the possibility that I use an odd number, plus 3 times 6 times 5 times 4. Does that make sense, guys? Right. Okay. Askis Annaliswa, this question is kind of one of those that is really okay. So how many do you get?
840.
Say that again.
840.
840. Did this guy give us the right answer? This one, 840. Yay! So AI does work. Okay, right, 840. Yeah? So those are the numbers, the number of possibilities that we have. Now, on the next one, and I'm going to take another one in fundamental counting principle so that at least I can help it land a little bit better. They say to you, calculate the probability. Now note, once they say probability, you're going to have to take the number of possible outcomes divided by the total number of outcomes that are there. Are you guys with me? Yeah? Right. So, calculate the probability that you will open the lock at the first attempt. If it is given that the code is greater than 5,000 and the third digit is 2. Okay? Right. Now let's look at it. How many possibilities do I have? If the number is greater than 5,000, right? And in this case, I am given, or rather they say that the third number is 2, right? So let's start with the third number. They said the third number is 2. So how many numbers can I use on digit number 3? There's only one number that I can use, and that's 2. Are you guys with me? Right. Please, I'm not putting in 2, I'm putting in the number of numbers that can be used. Right? So I can only use 2 over there. Does that make sense? Right. Now, and then secondly, they said to us it must be greater than 5,000. Now, I want you to note, greater than 5,000 means I now have how many digits that are left to use for the first number. I've got 5, 6, 7, 8, and 9. Make sense? Right. But now, what I'm going to do is, I'm going to again separate my scenario into odd and even. I think that condition still holds, right? The fact that, yes, because it was in the statement. So it must be still an even code. Are you guys with me now? Right. So I'm going to take even numbers for the first one. And in this case, I want us to note. Let's start with this possibility here. How many numbers do I have left? Right? I've already used 2. Please remember that. I need to have an even number over there. Does that make sense? How many numbers are left? How many even numbers can I use? Right, 3 more. Does that make sense? So, those are the 3 even numbers. Now, I want you to note this. Here, on the first digit, I've already used an even number there, right? And I've already, okay, that the even numbers that I have that are left over here that are greater than 5. Which are the even numbers that I have? In fact, I don't even need to separate it like that, right? Because in actual fact, it's only the numbers that are greater than 5,000, right? So, how many numbers do I have left? Right? So, you must keep in mind, I've already used one of the even numbers over there, right? Any of the even numbers. And I've got a number that is greater than 5 over there. So, I want you to note in this case, how many even numbers would I have to choose from? Right? 2. Isn't it? Right. So, those are the 2 even numbers that I can choose from. Now, I want you to please be very careful in this case, because we were not limited on which even number could be used over there, right? In fact, maybe let's do this. Maybe let's start with that even number over there, right? Let's start with the even number at the beginning, right? So I could use 2 even numbers over there, which means how many even numbers would I have left to use for the last digit? If I've already used 2, right? So I would have, remember, I've already used 2 over here. I've already used 1 from the upper values. So how many even numbers do I have? I've got 4 and I've got 6, right? Okay, but 6 is greater than 5, so I would have used 1 of them over there. So in actual fact, the number of even numbers that I would have, that I can possibly use is 2. No, actually 2, yes. Am I correct?
Yeah.
Am I correct?
Yes.
Yeah, so think about it. I need to hear how many even numbers could I use? I could use 6 and I can use 8, right? So now I've ruled out 2, I've ruled out 1 of these, right? I have 1 of this that's left, but I also have another one that's still left. Yes, I've got 2 that I can still use. Okay, and now for the 3rd digit, or rather for the 2nd digit, I can use any of the numbers that are left. Now I want you to note in this case, I've used 1 number, 1 number, 1 number. How many digits can I still use? Out of the 9, I can, no, sorry, out of the 8, I've got 6 digits that are still left. Okay, right, Askisuti, I took such a mean example when I have not developed your muscle on this section. Right, but we also have the possibility of taking an odd number here. Are you guys with me? Right? But we need to make sure that this number here remains even. Alright? So, how many odd numbers that are greater than 5? So I've got 5, I've got 7, right? So I've got 2 odd numbers. Do you agree with me? No, I also have a 9 as well. Yeah. So we've got 3 odd numbers that we can use. Are you guys with me? Now remember again, they said the 3rd number has to be 2. So that can only be 1. Alright? And then we need to use an even number there, and it doesn't matter which of the even numbers is it, but it just cannot be 2. Does that make sense? How many even numbers do we have left?
3.
We've got 3. Okay? And of course this becomes 6. Alright? So again, I know that yes, it is recorded in Kilebogile. You can watch it again much later. So that's 2,000, 2 times 6 times 1 times 2. Plus 3 times 6 times 1 times 3. And that gives us, what is this thing? What did it write? What's the number?
78.
Huh? 78. 78. Right. So those are the possible number of outcomes. But what did they ask us to calculate? The probability. Are you guys with me? So the probability of getting that digit right is the total number of outcomes divided, the number of outcomes divided by the total number of possible outcomes that we got. And I believe we got it 780, né? 780. 800 and what? 840. Right, so that's 78 divided by 814, and I get a probability of 0.0929. Okay, you got 72. I don't know how you managed to get that, but here's what I am going to suggest, guys. When it comes to the fundamental counting principle, I know it's the last section. Can you please just answer it at the end? Leave it out until you finish with everything else. Okay. Otherwise, it may frustrate you at times. And I don't know who chose this question, but this is one of those questions. Okay. It's not always like this, and I'll show you even as we try to build up. Right? I think there was another question on the that would kind of make our work a little bit easier. Oh yes, I think. Right. I don't know if this is visible. Okay.
Did you send it? I don't show it.
Okay.
Okay.
Right. I know that it's a little bit. All right. So they gave us in this question here. Please, I want you to consider. I know that it's not really the best in terms of how it's structured, this question, right? Because they took a snapshot. So they say in a certain country, we've got a 10-digit phone numbers, right? With the following format: it's area code, it's exchange code, and as well as a number, right? They say to us digits may be repeated. So once digits can be repeated, I want you guys to please note. So we've got a 10-digit number, so 10.1. They say to us how many possible 10-digit telephone numbers could be formed. So remember there are 10 digits. Right, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? So, my question is, if we can repeat digits, how many digits do we have in total? We've got 10 digits from 0 to 9, eh? Right? How many digits can I use in the first number? 10. How many digits can I use in the second number? No? 10. Remember they said they can be repeated. Okay? So it doesn't matter. Our phone number can be 111111 all the way. Right? It can be 22222. So we've got 10 digits. So notice for every different number, you've got 10 digits that you can pick from. Are you guys with me now? Right. So how many possible phone numbers can we make? 10 to the power of 10. Okay. Does it make sense, guys? Okay. I won't try to give you that number. Alright, I'll just write it, I'll leave it out as 10 exponent 10. Right. Now, for the next question, they say certain restrictions are placed on the groups, placed on the groups of digits. Now guys, I want you to please note this. They say area code. So the area code must be 3 digits, and the first digit cannot be 0 or 1. So let's talk about what this phone number looks like. And guys, please stay with me, nah? So that we are able to do this together. That's 1, 2, 3, and 4. So firstly, they say area code must have 3 digits, and it cannot be 0 and 1. The first digit cannot be 0 or 1. Okay? The exchange code must be 3 digits, and the first and second digit cannot be 0 or 1. Right? And the number must be 4 digits, and the first digit must not be 0 or 1. And now they want to find out how many valid 10-digit telephone numbers could be formed by applying the given restriction. Now let's start with the area code. Okay? So for the area code, they said the first digit cannot be 0 or 1. Okay, let's apply the restrictions. They said first digit cannot be 0 or 1. Are you guys with me now? Right. Again, which other one cannot be 0 or 1? For the exchange code, 3 digits. The first and the second digit cannot be 0 or 1. So for the area, this one cannot be 0 or 1. Another one cannot be 0 or 1. And then they also said to us, numbers must be 4 digits and the first digit must be 0 or 1. So this one definitely must be 0 or 1. I hope that we are clear, guys. Are we still good? Alright, now let's apply the restrictions here. Right? Let's start with the first one. So first digit cannot be 0 or 1. How many digits can we choose from? 8. Okay? For the second digit, how many can we choose from? How many digits can we choose from? 10. Remember, we don't have any restrictions there, right? We don't have any restrictions there, and they did say that numbers can be repeated. Okay, right, and then for the third digit, how many numbers can we choose from? 10. Also 10. Right. For the fourth digit, which is the first digit of our area code, right? They said it cannot be 0 or 1. How many digits can we choose from?
8.
How talk to me, guys? 8, right? They can be repeated, so there's no restriction in terms of repetition, right? So even if I've used it over there, I can still repeat it again. So I've got 8 to choose from. Again, for the second digit of that, I can choose from 8 because it cannot be 0 or 1, right? And then, how many digits can I choose here?
10.
I can use 10. And then, they said this one must be 0 or 1, right? How many digits can I choose from? 2. Okay, and the next one, how many? 10. It's 10, and that's 10. Make sense? Alright, so that is the number of possible outcomes that we can have. They said how many 10-digit telephone numbers could be formed by applying the given restrictions. So all you simply do is that you're going to now multiply all of that times 8, times 8, times 10, times 2, times 10, times 10, times 10. And what does that give us? I get that big number there. One, 0, 2, 4, and how many zeros?
1, 2, 3, 6.
Is it like this? Right. I do, Lindos, I agree, probability, yes, and sometimes it really can show us flames, but please, I will give you advice just at the end, on really how to approach the exam, all right? I don't think we'll be able to finish off on all the questions. If you can persuade me enough, we can try this again on Saturday, maybe for paper 2. We'll see in terms of time. We'll also interact with our online audience. All right, now the last question here. Yes, yes, ma'am. I need to go back, yes?
So then, why is it that for this one did we multiply the different probabilities of different events and not add them?
I can't
Why
hear
is
you well.
that for this one? We multiply the different probabilities instead of adding them.
Why is it for this one we multiply the different probabilities? Okay, yes, okay. So in probability, whenever you've got a possibility, when we use or. Now, in the previous example, you had two possibilities. You could use an even number or you could use an odd number. You with me now? So the moment that you say or, then it means that there are two permutations that you need to factor in. So then I separate them. I say, well, let's deal with the possibility where we use an odd number, right? And see what the possible outcomes are. And then for the or part, you always add. Okay, right. And then you say, for that even number, what could I possibly use? Here, you are just simply dealing with a possibility of digits. You are just using, and because repetition was allowed, they did not give you restrictions in terms of even number or odd number. We could use any of the digits. The only restrictions were around 0 and 1. Okay? Right. Awesome stuff. All right. And that's a good question. All right. Now, I want to go and look at the final and the last question. They say to us, determine the probability that any random number chosen, any chosen 10-digit telephone number would be a valid phone number. Now remember, once you've done the possible outcomes, so the probability just simply says the number of possible outcomes, which is what we had, those are the phone numbers that we've got, divided by the total number of possibilities. And where was the number of possibilities? It was the first one that we had. Does that make sense? Right. So you've got 1024 000. Okay, I'm looking at you and you look very defeated right now. Okay, right. So this is 10 raised to the exponent 10. So don't worry. Remember, in class we haven't really covered this, nah? So what I have not done here is to really build up your understanding on this section. So, and this is a very dangerous way, and that's why I was saying to you, about this line, certain things look difficult at the beginning, but the reality is that, you've seen in class, right? That once I get to build up, your understanding on a particular topic, right? It then becomes easier to then, which is what we call scaffolding, right? It's easier to then add layers of knowledge upon knowledge, right? But in this case, what I just simply did was just jump, and you guys sent me the most difficult of questions without having had prior engagement on this section. Okay, right. So for our online people, right, guys, I am going to perhaps leave the lesson here. But can I give you guys some advice when it comes to the exam that you're going to now, the Matric exam? One, I want you to always realize it's still the same curriculum. So essentially, in terms of difficulty, in terms of the number of level 4 questions, the distribution is always the same, right? I will admit though, that Matric exams might be slightly, a tad bit more challenging than the November exam. I think, deliberately so. And the reason is simple. Think about it. There were people that were meant to write in November who couldn't, right? Due to different reasons. Maybe you fell ill or whatever the case is, right? And so what happens is that you've now had more time, a longer amount of time to prepare than the person who was writing in November, right? That is for those who are writing it as a supplementary exam. There's a difference. For supplementary exam, you are actually, it's when you missed writing in November and you couldn't actually write at that time. And so they're giving you the possibility of writing now. But when you are writing it as a for the second chance program, or you know, as a rewrite, okay? In that case, it doesn't become a supplementary, now becomes an upgrade or rewrite, okay? But you are all writing the same exam, okay? So, one, I'd say to you guys, please don't panic, right? I always say the approach to the exam should always be such that start with the section that you are most comfortable in, right? So, if for instance you're going to say to me, I'm more comfortable with, let's say, functions, right? Start with functions, okay? Because in that case, what it will then help you to do, if you're like me, I get into the exam, there are butterflies in my stomach, I am as nervous can be, right? So in order for you to be able to calm yourself down, you need to get to that point where you actually just ease yourself into the exam, right? So that you realize what it's the same thing, you know, that you're being asked. So what I'm just simply saying, guys, is that please just make it a point that your approach should always be to start with the section that you've got more experience or you are more comfortable in, right? And work your way towards other sections. Now, of course, you leave out the one which is the least comfortable. For instance, you already know the questions are 1.3, right? 1.3 by hook or crook, you're going to get those level 4 type questions, you know, that are kind of crazy. You need to think of something on the spot, or you need to be very creative mathematically to be able to answer those questions. Already you know, that one you can leave it for the end, okay? And in my case, I would say to you, the sections that really I want you to make a meal out of are your functions, right? Already, guys, you know that by doing your functions, you are over 40% through your exam, right? So please perfect those. You also know that you are going to get optimization. Sometimes it can frustrate you. As Kisuta wasn't able to get to questions as an optimization, but there's lots of questions that I've curated on the channel that you can also have a look at. Please go on to playlists. Look at calculus playlist. You'll see that there's also some questions that I've done on the said question. Okay, yeah. So I am just asking, guys, when you approach this exam, I understand that you know, some of you might not be as ready can be, but try to do the best that you can. And there's also the group that is also writing for the senior certificate exam. For those of you that are online, I hope that you've been able to, you know, ask questions, or rather, you know, attempt the questions that are there on the channel. And please, guys, we are going to continue with these live sessions, right? I love the fact that there's an audience, so I can now and then look into their eyes and see if they are confused. If they are confused, then I know there's confusion online as well. So we're going to continue. And for those of you that are members on the channel, we will do this a bit more frequently than we do for other people, right? And we will let you know whenever we are going live. I think the next time that we will see each other will be on Saturday. We will confirm time. I think the afternoon might work a little bit better on Saturday. But just like I asked right now, please bring in the questions that you'd like for me to answer. For those of you that are online, let me see. I was meant to give a shout out to someone. I was meant to give, she sent a message, it was a birthday today. Can someone share if you are available? Please let me know. Okay, and yes, the mic will be safe. there are any questions. All right. I think with that said, thank you so much to all of you that are online for watching. It's really been a pleasure. And for our live audience, yay! For our first YouTube live, when I am giving a lesson. All right, guys, I don't have much time, but I'll try. If there are any questions, but I need to go off from the live. So I'll just hang around here just a bit to address your questions. Okay. From all of you online, I'll see you guys next time. Ciao, ciao. Okay. All right, you can end the live talk, please.
Are you sure that you want to stop streaming?